Section 8.3 is on interpreting data. So we're going to look about how outliers affect mean, median, and mode. We're going to talk about range and talking about how they use these estimates, how they use mean, median, and mode to make estimates for things. So outliers we've already talked about a little bit. Those are numbers that are much bigger or much smaller than other numbers. And it's kind of a gray area there, you know, what makes it much greater or much smaller. Part of it depends on how big the numbers are. Like if I have 1, 2, 3, and 40, 40 would be an outlier. It's way bigger than those other numbers, okay? That's a difference of 37, okay? Now, if I had some bigger numbers, well, let's just say we have 501, 502, 503, and 540. At that point, those numbers are pretty big. So I don't know at that point if I would necessarily consider 540 to be as much of an outlier, really. Okay, so it kind of just depends. There's not really a set formula. Well, I say that. When we get into box and whisker plots or box plots, they will actually talk about, they do actually have a thing, and maybe I'll try and mention that later in this lesson, a way that they figure out if something is an outlier. So I take that back what I said. There is actually a formula that they use. So we've already mentioned a little bit, outliers have the greatest effect on the mean and the range. The mean, we're averaging the numbers out. So if you have a number that's way bigger or way smaller, that's going to really affect your average. Just like in school, if you get a 0 on something, that's really going to bring down your grade. The median gives a best description when we have an outlier, because the median is not affected as much by the outlier. It's just the number that's in the middle, or the average of the two numbers that are in the middle. So as an example, 6 students are taking a film class. The table shows how many films each student has seen so far this year. One number greatly differs from the others. How does it affect the statistical measures you would use to describe the data set? So if you look at the numbers here, how many films the student has seen this year, okay, and they highlighted it for us here in red. 104, that's way bigger than the other numbers. And so we're going to talk about exactly how the outlier is going to affect it in this particular problem. So for the mean, with the outlier, if you look on the left here, with the outlier, we're adding those numbers together. There are 6 numbers, and we get a mean of 27. So it's like we're saying on average, people watch 27 movies. Well, if you look at that, there's only one person that watched more than 27 movies out of the 6. So 27, that seems way off from most of the numbers. If we take the outlier out of the equation, if we just figure without the outlier, the mean is 11.6. So 11.6 versus 27, that is a big difference. So the outlier really changes the mean. And that's why we're going to show here the median, and the median is not going to be as affected by that outlier. So for the median, with the outlier, we have 2 middle numbers. We average those, we get a median of 12. So median of 12 with the outlier. Without the outlier, we have 1 middle number, we get a median of 11. So the median was either 12 or 11, but the mean was either 27 or 11.6. So that's why if you have an outlier, it's going to be better for you to use the median. Okay, and then so they talk about also how If the outlier is one extreme value, it can't affect the mode, because if it's only one number, it wouldn't be the mode. So one number isn't going to change the mode. You'd have to have multiple, either really big or really small numbers to affect the mode. We can also look at the range. With the outlier, the range 104 minus 8, we have a range of 96. Without the outlier, 16 would be the biggest number. 16 minus 8 is 8. So 96 versus 8. The outlier has a big impact on our range as well. So if we look at this problem, we're going to look at number 1. First, they want us to identify the outlier. And then they want us to find the mean, median, and mode, both with and without the outlier. So we actually have like 7 different answers on this problem. What is the outlier? What's the mean with the outlier? What's the mean without the outlier? What's the median with the outlier? What's the median without the outlier? What's the mode with the outlier? And what's the mode without the outlier? So really 7 different answers in one question here. One thing you probably want to do to start out with is put the numbers in order. So on this problem, if you look at the numbers, we need to identify the outlier, and it's usually going to be fairly obvious. So our outlier here is 32. It's quite a bit bigger than the other numbers. Okay. Then we're going to look at the mean. So for the mean, we have to figure it both ways. We have to figure with the outlier and without the outlier. You guys are doing quite a bit of work on these problems. So I know in the last lesson we might have talked about you need to write down, add the numbers, and then do whatever. You guys are doing quite a bit on this, so if you want to just actually find the total without actually mentioning that you're adding the numbers, that's probably okay. So we've got the mean with the outlier and the mean without the outlier. So with the outlier, if you add the numbers, would be 72 divided by 6 would be 12. Without the outlier, 40 divided by 5 is 8. Okay, so you can see that did bring up our mean a little bit from what it was. The median, same thing. We're going to look with the outlier and without the outlier. So with the outlier, we have 2 middle numbers, 7 and 13. So we're adding those and dividing by 2 would be 10 with the outlier. Without the outlier, if we think of removing that 32, then we would only have 1 middle number, which would be 7. So without the outlier would be 7. So notice, not quite as big of a difference on the median as there was for the mean. And then the mode. Now for the mode, if it happens to be the same either way, you can just write the number and then just say either way or something like that. So the mode. So with the outlier, our mode is 13. 13 happened more than the other numbers. We take the outlier out, then the mode is still 13. So the mode is going to be 13. We could say 13 either way. So statistics that indicate how data are spread out or distributed are either called measures of dispersion or measures of variation. I've seen them more called measures of variation. They tell how varied the numbers are from each other, how much they vary. So the range is one example of a measure of variation. Okay, the range, we're looking how spread out the numbers are from the smallest number to the biggest number. The book points out it's not a measure of central tendency. The book says because it does not represent the data values. I think it's not a measure of central tendency because it really doesn't indicate where the center of the numbers is. Mean and median kind of have to do with the center of the numbers. Mode is arguable because the mode could be our smallest number or our biggest number. I've always kind of questioned calling the mode a measure of central tendency because it's a lot of times not in the center at all. So that kind of seems an odd name for it. But so anyway, if we look at this, here's an example of how we could have the same range but different means, medians, and modes. So if you look at set A, 4, 12, 25, 36, 40, 41, 41, 44, you can see the mean, median, and mode there, but notice it has a range of 40. Set B, we got 27, 28, 28, 29, 30, 50, 67. That one had actually a little bit variation there. The mean was higher, the median was lower. The mode, who knows what the mode's going to do. It happened to be smaller in this case, but it had the same range. So like I said, the range really is just telling you how spread out the numbers are, and it doesn't necessarily tell you like if you have an outlier or don't have an outlier. It definitely, like we saw earlier, the range is definitely affected by outliers though, because you're either getting a higher or lower number that's going to increase your range. So here are some examples of how these measures of central tendency might be used in real life. So like DVD rental services, so like you guys have seen like the Redbox and stuff like that. They look at the customer preferences. They estimate maybe how many of each DVD to keep in stock, maybe by using the mode in order to order the movies people see most often. So they can try to make sure they stock their machines that they don't run out of that movie that people want, and that people can still be able to rent it. Statisticians might use the median to compare prices of houses, how the median price of houses changed from 1 year or over a period of years. Notice they're using median there. They're not using the mean because there could be definitely outliers with houses. So like houses, I just saw an example the other day. I think a house got listed for like $8 million. Okay, yeah, so that is definitely going to affect the mean. It's not going to affect the median as much, okay? And then teachers use the mean score, and sorry, but it doesn't matter. If you have an outlier, we're still going to use the mean. We're not going to use the median. You're probably not going to convince the teacher, well, since I have an outlier, it would be better if we use the median than the mean, right? So this gives you an idea of how to interpret data. Have a good day.